On the board are all the elements and all the atoms and polyatomic ions on your sheet from yesterday. Now, we're going to go through this very methodically. All right, we're going to go through it very methodically. By the end of class today, when I say how well do you understand this, I want everyone to at least be a 3 out of 5. That's the goal. Is it in here? Is it outside?
No, it's in here. No, it's in here.
That's outside.
It's in here. It's in here.
All right. So
Yeah, it's in here. I smell it.
we have, we want to go through this very methodically so that you can repeat this process. You guys let Sarah in. So here we go. Let Sarah in. All right. I'm going to go through and put all the charges on first. So 4 plus, how do I know it's 4 plus? Because IV is 4 and it's a metal, so it's a 4 plus. Permanganate, you're memorizing. 1 minus. Phosphate. Phosphate. 3 minus. Magnesium is in group 2, so that's 2 plus. Calcium, 2 plus. Oxygen, 2 minus. Nickel. Nickel 3, so it's 3 plus. 1 minus for fluorine, and no charge on argon. And then let's mark whether they're a metal, non-metal, or a polyatomic ion. So titanium, metal. Now, I had a group of people in second period who couldn't remember how to tell that. First of all, if they're just an atom, if they're a plus, they're metal. If they're a minus, they're non-metal. All right? And secondly, just look at the periodic table. Remember the stair steps I had you color. Everything on the left of the stair step is a metal. Everything on the right of the stair steps is a non-metal. Anything on the stair steps is a metalloid. All right? Metal, permanganate is polyatomic. Phosphate, polyatomic. Magnesium is a calcium. Oxygen. Nickel. Fluorine. And argon, non-metal. All right, I'm going to go a little bit out of order here. I'm going to start with number 3. Which element or polyatomic ion is unreactive, and how many valence electrons does it have? That's pretty simple. Which one is unreactive? Argon. AR, argon. Now, the worksheet is a little bit confusing. I use this is basically what was on the test last year with different elements, and it confused people, and they put 1 there because every other one of the tables says how many atoms. This one says how many valence electrons, if you read it correctly. Should be 8 valence electrons. On your test, I'll make sure you can tell what I'm looking for. I'll make it consistent in some way. All right? Argon, AR, 8 valence electrons. Is argon going to bond to anything?
No.
So what can we do? We kind of get rid of it and not worry about it the rest of the time. All right, we got argon done. Let's look at number 1. Form 2 binary ionic compounds. We're looking for binary ionic compounds. What does that tell us? Binary ionic. Binary tells us there are how many atoms bonding together? 2. Binary. So 2 atoms. And ionic tells me what?
Metal and non-metal.
Metal donating to non-metal. 2 atoms, 1 metal donating to 1 non-metal. Guys, make sure I go over the back of the worksheet because I did that first in the other classes and I forgot. So let me come back to it. 1 metal, 1 non-metal. So we're looking for 2 atoms that need to get rid of the same number of electrons. All right? Now, can I use these for this problem?
No.
Why?
Because it's metal and non-metal, not polyatomic.
Right, it's a metal and non-metal, and I'm only looking for 2 atoms. These already have 2 or more, right? And so if I bond them in, they're going to have at least 3. That's too many. So I cannot use these for this part of the problem. So I'm just going to put a little mark so I remember that. Don't use those, Nathan. I talk to myself in third person a lot while I'm working. Titanium. Is there anything that needs 4 electrons? So can I use this for this? No. Put a little mark out. Magnesium has to get rid of 2 electrons. Is there anything that needs 2?
Yeah.
Which one?
Oxygen.
Oxygen. I can do Mg and O. 2 plus on the magnesium.
2 minus.
There's oxidation numbers. Which one's the cation?
The energy.
The 2 plus. The Mg and the anion, the 2 negative. All right? So MgO, and that is
Magnesium oxide.
magnesium oxide. Is there anything else that needs 2 electrons?
Oxygen and calcium.
Anything else that needs 2? We did this one. That's a metal and a metal. This needs 1, not 2. So I'm done with magnesium. Calcium needs to get rid of 2. Is there anything that needs 2 electrons?
Oxygen.
Oxygen. All right. So CaO, 2 plus, 2 minus. Now, what do you notice about calcium and magnesium? Same. I almost put calcium, magnesium. Calcium oxide. They have the same number of valence electrons they need to get rid of. So anything one could bond to, the other one could, right? In theory, anything that I could bond one to, the other one could bond to. All right. So I did calcium, the oxygen. There's nothing else that needs 2. And the only other metal I got left is nickel, and there's nothing that needs 3, right? I asked for 2, I have 2, right? So that's all of that one. Binary ionics, there are 2, magnesium oxide and calcium oxide. All right, next, I'm going to skip down to the bottom. Form 5 ionic compounds that have 2 elements and at least 3 atoms. Ionic compounds with 2 elements and 3 plus atoms. So that tells me I have 1 or more atoms of a metal donating to 1 or more atoms, all right, of a nonmetal. Again, what can't I use?
Polyatomic bonds.
Because,
It doesn't say.
well, it doesn't say we should, but what's it say?
Ionic.
No? What else?
2
2 elements, right? I'm only using 2 elements. These already have 2 elements each. All right? These already have 2 elements. If I put them with something else, I got 3. This says to use 2 elements. So I'm not using those 2. I'm still not using argon either. All right? Now, again, being very methodical here. Titanium. Are there any nonmetals that I can put titanium with? All right, well, this is a metal, so no. This is a metal, so no. Oxygen. Could I put titanium with oxygen? How?
2 oxygens.
2 oxygens. It gives 2 to this oxygen, gives 2 to another oxygen. TiO2. 4 plus and 2 minus. Very good. 4 plus, 2 minus for our oxidation numbers. And this will be called titanium, and very important, 4 oxide. Do it the old way, we'd have titanic oxide.
Yes.
Where's Kate Winslet when I need her? All right. I saw on several papers this incorrectly done. Like that. That's not correct. When we're writing the formula, we just put the 4 plus. That tells us it's 4, right? We don't need to write Roman numerals. The 4 plus tells us it's 4. Okay, so I did titanium. I skip. That's a metal. That's a metal. I did it with oxygen. That's a metal. What about titanium and fluorine?
Yeah.
How so?
4
4 fluorines. Very good. They each need 1. I give it 1 to each of 4. Ti, 4 plus, F minus Need 4 of them. Titanium, 4 fluoride. And I am now done using titanium for stuff on this problem. Done. Permanganate, not worried about. Phosphate, not worried about. Let's go to magnesium. Are there any nonmetals left that I can put magnesium with? Magnesium, calcium's a metal. What about oxygen? We already did that, right? It's a binary. All right. Nickel, no, that's a metal. Fluorine, magnesium and fluorine.
Yeah.
Yes, how?
2 fluorines.
2 fluorines. Mg, 2 plus, F minus, we need 2 of them. Magnesium, fluoride. Now, I did see some people yesterday get really excited and they put magnesium 2. Don't need that. It's not a transition metal. It's got to be 2. It's always 2. All right? I only need to put Roman numerals when it's a transition metal, if it was given to you that way in the problem. Magnesium fluoride. All right? And we've already determined anything I can do with magnesium, I can do with calcium. Ca, 2 plus, F minus 2 of them. Calcium fluoride. So I did magnesium with oxygen over there, and I just did fluorine. Done with that. Calcium with oxygen I did over there. Metal, fluorine I just did. So I'm done with calcium. Getting short on metals. It's the only metal I have left. Nickel, and I need one more answer. Now, if you gave me a weird answer on a test like this, I would take it. That's not what I'm looking for right now, but I would definitely take that. Because what we're looking at, if I give 2 electrons to oxygen, what's wrong? There's 1 left. So if I give it to another oxygen, that oxygen still needs another one, right? Well, if we give it to another from another nickel, that nickel's going to have 2 left after that, right? Does that make sense? So what you ultimately end up with is that ONO, which would be N2O3. All right? That's not what I'm looking for. As far as we're concerned, there's not an easy way to do that. What about these 2? Nickel and fluorine. Right. So the other is not incorrect. I'm not looking for anything that complicated right now. So Ni, 3 plus, F, 3 with a -1 charge. And that is nickel, what is the name? Nickel 3 fluoride. We're going to come back and do the number of atoms at the end. So it's all of that one. Now on your paper I asked you to find 3 polyatomic with metal ionic bonds. There are 5 though. There are 5 correct answers. So we'll do those. The wording is 3 ionic compounds that have at least 1 polyatomic ions. So I need ionic with polyatomic. So that tells me that every answer is going to have either what or what? Right, everything's going to have either this or this. Everything's got to have permanganate or phosphate, right? Because they have to have a polyatomic ion. Really, I'm just looking for what I can bond with these. Okay. So, let's start with titanium. Can I do titanium with permanganate? How? Just like I did with fluorine, right? Fluorine needed 1. Permanganate needs 1. Alright? Ti, and then I need 4 permanganates. Ti, 4 plus. And this is where a lot of you get confused, so make sure you're listening with your face. MnO4. That's permanganate, right? I need 4 of those. How do I do it? And then we call that titanium 4 permanganate.
So you don't change it to ID at the end, just leave it.
Just leave it how it was. Yep. They're already renamed, kind of like on your periodic table, all the others are renamed. All right, what about titanium and phosphate? I give 3, I got 1 left, I give 1 to another one, 2 from another, that's a train wreck, right? So we are done with titanium, because remember we're doing everything with these 2 negatives. We're looking for positives. Are we going to be able to use this at all?
No.
Because why?
Negatives.
They're negative, yeah, right. We're not going to be able to use that, we're not going to be able to use that, we're not using argon. I'm really just looking for these metals here. What about magnesium with permanganate?
Yes.
Yes. How?
2 permanganates.
2 permanganates. Mg, MnO4, 2. Magnesium, permanganate. And we've already determined, again, what about magnesium?
Anything you can do with
Anything
magnesium.
I can do with magnesium, I can do with calcium. Ca 2 plus, MnO4 minus 2 of them, calcium permanganate. What about magnesium or calcium with phosphate? Not very simply, no. Right? Complex molecules, complex compounds we're not getting into. All right, so I'm done. I'm done. What's the only metal I have left? Nickel. Nickel 3. What about nickel with permanganate? Yeah, how? 3 permanganate. Ni. 3 plus, MnO4, we need 3 of them, and I call this what? Nickel 3 permanganate. And the only other option I have left has to work because I told you there were 5. Nickel needs to get rid of 3. Phosphate needs 3. So I just need 1 of each, right? Ni, 3 plus, PO4, 3 minus. I don't need any parentheses because I only need 1 of that group. Ni, PO4, and that is nickel 3 phosphate. Minus the number of atoms, those should have been the answers on your paper. You're only asked to find 3 of these, but those should have been the answers. On your test, which will be Tuesday, you'll be expected to do this, and this will be a point each, and the names will be a point each. The number of atoms will also be a point each. All right, so that I think on the test that's online from last year, there are 36 possible points on that page. Mess up that page, you get 64 or less. All right, number of atoms. Let's start with the easy ones. How many atoms are here? 2. 2. One magnesium, one oxygen. They're binary. They have to be 2, right? 2 atoms. That's the whole point. All right? So there's 2 and 2. Ask questions if you have them. Some teachers say there's no such thing as dumb questions. There are definitely dumb questions. If you ask one, I'll let you know. However, you're learning junior, senior level chemistry. Ask questions. They're probably not dumb. All right? And a lot of people were really confused on counting atoms earlier that I need to straighten out. So if you don't get it, ask questions. How many are here?
3.
I have 1 titanium and 2 oxygens for a total of 3. 4 fluorine and 1 titanium. 5. 2 and 1. 3. 2 and 1. 3. And the last one, I have 3 fluorines and 1 nickel. 4. This is where a lot of people have a little more trouble. We're not doing our multiplication correctly. How many are in 1 permanganate here?
5.
We have 5. And 1 manganese and 1 oxygen. That's 5. I have 4 of those. 5 times 4 is 20 plus the titanium. 21 atoms in that structure. Here I have my permanganate, which is 5. I have 2 of those, so that is 10, plus my magnesium is 11. I have 5 again, and permanganate times 2 is 10, 11. Those should always match because it's calcium and magnesium. Okay, nickel permanganate. I have 5 in permanganate, as always. I have 3 of those, so that is 15, and nickel makes it 16. And then I have 1, 2, 3, 4, 5, 6. 4 oxygen, 1 phosphorus, 1 nickel, for a total of 6 atoms. So your answers on that side of the page should look like this.